And so that means autonomy. That means, simplifying everything down to a single button. That means no fiddling with SD cards. The data has to flow directly into the cloud. It means compliance. It means that it has to operate, everywhere, both within and away from cell networks. So it's just like, imagine like another bit of sort of dusty construction equipment. This one just happens to be a flying robot.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 126. How are drones used in the construction industry? That's the question we explore in today's show. Chris Anderson is the CEO of 3D Robotics, founder and chairman of the Linux Foundation's Dronecode Project, and founder of the DIY Drones and DIY Robocars communities. From 2001 through 2012, Chris was the editor-in-chief of Wired magazine. Before Wired, he was with the Economist for 7 years in London, Hong Kong, and New York. He has led 3DR from a startup to drone manufacturer and now to a drone services company. In this edition of the Drone Radio Show, Chris talks about how drones can be used in the architectural, engineering, and construction industry, and how 3DR is positioning itself to serve this critical sector. He'll also share some thoughts and perspectives on the drone industry itself. Now, before we hear from Chris, if you like the Drone Radio Show and you want to help expand its offerings, please consider supporting my funding campaign. For as little as $1 per month, you can help defray the costs of production and keep the show going and growing. Go to patreon.com/drone radio show. Now let's hear how drones can be used in the construction industry with Chris Anderson. Let's pick up the interview where I asked Chris to introduce himself.
I'm Chris Anderson. I'm CEO, co-founder of 3DR. We are based in Berkeley. Been one of the pioneers in the drone industry, starting back in the days of the early community of building drone technology all the way through the consumer phase. And we are now 100% focused on drone data, especially in the construction industry.
I think most people are familiar with the story of 3D Robotics, but can you walk us through how it evolved into a drone services and software company?
This started, as you know, as a community back 10 years ago. Actually, it was not a company until midway through. But, I had no intention in, being in the drone business. My background is, as you know, I was former editor of Wired. My training's in computational physics. And I was just drawn to drones simply because it was a robotics challenge that was unmet at the time. And it was fun and interesting, and we could make some progress there. But the intention was not to build robots. The intention was to put sensors in the sky. That is fundamentally the job of everybody in Silicon Valley, is to extend the internet. Some people extend to companies, some to homes, some to wrists, some to cars, some to streets. I saw an opportunity to extend the internet to the skies by gathering data from below the clouds, below the satellite layer, but above the ground, and then to make those devices smarter by connecting them to the internet. So a classic sort of smartphone with propellers strategy. So that was always the plan, was to make it about the data and about the sensors. But the question was what data? What's it good for? How will it be used? And that just took time to find the sector, where aerial data would be most useful. We considered agriculture, we considered, search and rescue, wildlife conservation, all that kind of stuff. And we did all of that enough to realize that either areas where we didn't have a lot of domain expertise, like agriculture, or they were really complicated, or there weren't really financial models, or they were highly regulated. And eventually we ended up spending more and more time with Autodesk, which is the leader in the construction software industry. I'm good friends with the former CEO, and saw a real convergence between where the construction industry was going in terms of digitization and what's called reality capture, and what drones could offer. And so about 3 or 4 years ago, we started a collaboration with them, which just revealed the path forward.
It sounds like it was the collaboration with Autodesk that led you into the construction industry, as opposed to looking out at the industry sectors and saying, okay, let's focus on this specific industry. Is that a fair assessment?
I think we kind of reverse engineered the logic. It's basically, we had a practical project with Autodesk involving integrating the capture part into their reality capture program. And it was in the course of doing that that we learned more and more about AEC, which is architecture, engineering, and construction. We learned more and more about that business. We spent more and more time with customers. And over years, we started to understand, the underlying pain points and economics of that business. Now, it's, when you pull back, of course, it's the second largest industry in the world. It's one of the least digitized industries in the world. It's in many ways highly inefficient and not protected by, subsidies or some of the things that block agriculture from innovation. So it's a no-brainer when you pull back, but that's not the way. We didn't come at it like a management consultant, trying to find big sectors. Instead, we were drawn to it by a real-world collaboration.
Let's talk about the applications. How can drones be used in the architectural, engineering, and construction industry?
The way construction works is there's basically three phases. There's before the construction, there's during the construction, there's after the construction. So before the construction, you have a site. And that site may have something there, like a brownfield, grayfield. Maybe it doesn't have something there, and you need to characterize the site. So typically you scan it, and you get a sense of what's there. And that's called a design surface. And once you scan it, that's something the architect can work with to design what will ultimately go there. Then once the architect wins the bid, then you have the building phase. And the building phase starts with a very high resolution survey grade scan. And that creates what's called an engineering surface. And this is like so precise that the civil engineering company will actually design the entire workflow and where everything goes right on that scan. And then as construction happens, there's moving earth, there's digging trenches, there's putting down concrete, and all those things lend themselves to digitization, to scanning, so that you can check for errors, you can monitor progress, you can update the model, the digital model as things change, et cetera. And then finally, once you're done, then you have a building. That building has now been fully digitized because everything about it was digitized during the process. And then you can now manage the building and inspect it using the same tools you used to design and build it. And so this overall life cycle is called building information modeling, BIM, and it's the biggest trend in construction. It's the notion that the digital tools you use to design a building should be used to manage the construction and the ultimate building itself. So you have a living model of a building and then a living model of the surrounding area and the city. And it's the notion of a digital model of the world we live in.
Is that a process that construction managers are doing today, but with inefficient tools? Or is it something that's really beyond their current reach and capabilities?
That's a great question. And the answer is, a little bit. It depends on the company. By and large, this is a multi-decade process of digitizing the construction industry. Some companies are very progressive and have done it, do BIM, building information modeling, pretty much end to end today. They're more the exception than the rule. Some countries, like Japan and the UK, have now mandated for state-sponsored projects. So there's elements of reality capture that are happening today, but they're spotty. So, for example, using a high-precision GPS in surveyors and putting ground control points, and then putting on something called a total station, which is kind of a laser rangefinder that allows people to kind of, check the locations of different parts of the construction as it's going up. That's been happening over the last 20 years. And sort of the rise, if you see these tripods and you see it go by a sign and it says, on a construction site, it says, warning, lasers in use. That's probably one of these total stations. So that took about 20 years, and that's pretty common, but not ubiquitous. The use of high-precision GPS, like RTK GPS, that's taken also about 20, maybe 15, 10 years, and that's not ubiquitous. And then the notion of laser scanning, indoor typically laser scanning, that's also been underway for about 10 or 15 years and is not ubiquitous yet. So there's a lot of different technologies that contribute to this notion of digitizing the construction site. Drones are just a new one. Drones have the ability to do those things like laser scanning and RTK and total stations. They have the ability to do that for the entire site very cheaply and quickly. So there's this notion that is a kind of, call it a one-stop digitization tool. And that as the drones get more autonomous and higher precision, and the data pipeline is better, then maybe they can start to substitute for more of these, point digitization solutions and become the preferred scanning tool.
It also offers a way for companies that maybe didn't have the resources for BIM to begin introducing those concepts or techniques into their workflow.
Yeah, that's right. So today, if you want a survey, you hire a surveyor. And surveyors are excellent, but they're, expensive. And so you might have them once or twice. The notion of a drone is that you have a box on site, and that rather bring in a surveyor once or twice, instead you survey every day, or maybe even every hour automatically. And this makes surveying or scanning a commodity that's so easy and cheap that it becomes standard practice.
I recently ran across an article about an architect who uses drones in the design process. Like if he wants to see the view from the 37th floor, he would take the drone up and see what the view was actually going to look like. He said it gave him a different perspective on designing the building. Does that kind of application fit into what you're talking about?
So that use case of simply visualizing what a view would look like, that is certainly a use case. It's not sort of part of the BIM process. It actually falls into the sort of earlier stage of, kind of marketing things that you might do to win a bid or maybe to win a customer to a building. Some of the earlier drone applications that were largely just taking a video or maybe, just taking some pictures of a site, visualizing, et cetera. Those are still in demand. But what we're doing today is much more aligned with kind of traditional engineering data, which is to say that we don't just take photos. These photos get combined into 3D models, 2D models, point clouds. They're georeferenced within a centimeter using ground control points. They're then integrated with other data. So it's much more like an engineering approach than it is like an aesthetic, a visual approach. They're both good, but we're focused more on the sort of professional construction tool side, which is where Autodesk is focused as well.
Let's talk about 3DR's site scan product for a moment and how that fits into this process. Can you tell us about SiteScan, what it does, and some of its key features?
SiteScan is a cloud software solution. It has, like others in the business, we support the main vehicles out there, DJI Phantoms, the M210 series. We support our own Solo-based vehicle and with its Sony R10C camera. So it's a modified version of Solo.
So it's primarily a software.
Yeah, SiteScan consists of basically two software elements. There's the iPad app, which is essentially the ground station mission planning. And that's basically, it's easy to do the usual stuff of defining a mission. It can be a perimeter scan or a 2D scan or a 3D scan, et cetera. But by and large, that's just a swipe. The mission's been recorded and anybody can just open up the app and swipe and that would launch it. It's all autonomous. All the data is captured from, on the drone, automatically transferred to the cloud. So no fiddling with SD cards, et cetera. So that's the sort of the easy part. The really important part is what happens with that data. Once it gets into the cloud, it's then run through various photogrammetry engines, either the Pix4D engine or the Autodesk Recap engine, depending on the different kinds of data formats. There's a bunch of analytical tools, volumetric calculations, change detections, clash detections, ground control point integration, all that kind of stuff. And then the important part is that it then integrates into the rest of the Autodesk suite, which is, there's things like Revit and Civil 3D and BIM 360 and even AutoCAD. It sounds a lot like plumbing, enterprise, workflow software, but that's actually what the industry wants. Is they want the data to sort of magically appear in the tools they already use. That's accurate, that's easy to use, that's up to date, and they just want to push a button on an iPad and just have it happen. And we spent a lot of years doing that, but that's where we are.
I was going to ask how easy it is to operate, but it sounds pretty simple.
Yeah, so in the construction industry, there is absolute demand for one-button solutions. Nobody, drones may sound cool, robots may sound cool, but fundamentally, these are construction workers. They want a box with a button. And, maybe that button's on an iPad, maybe it's on the box itself, but they don't want to touch sticks. They don't want to pilot it. They don't want to introduce human error. They just want it to be like a generator or any other piece of construction equipment that just works. And so that means autonomy. That means, simplifying everything down to a single button. That means no fiddling with SD cards. The data has to flow directly into the cloud. It means compliance. It means that it has to operate, everywhere, both within and away from cell networks. So it's just like, imagine like another bit of sort of dusty construction equipment. This one just happens to be a flying robot.
Yeah, I agree. From my experience with dealing with contractors, they'll shy away from anything that would make them unsure, even remotely, about meeting a deadline on a major project.
Exactly. And also imagine a technology that requires a specialist, like a surveyor, to deploy. It's like, okay, well, the surveyor's busy, the surveyor's not here today, or the surveyor's expensive, whatever. It just doesn't happen. So, the way you go from occasional scanning to constant scanning is by making it something that doesn't require a surveyor, so that any construction, worker with a Part 107, license, and they all have licenses in one thing or another. Any construction worker could just push the button and it happens. And then you have a drone on each site rather than one drone per company being carried around from site to site by a specialist.
What differentiates your software and your service from other platforms?
We like to think that our software has got the coolest features and the best quality. And in some cases it does. But the main thing is that everybody in our industry, and we have, a number of really good competitors, we've also stabilized on a standard approach, which is you support DJI vehicles and maybe another. And then you're partnered with somebody. So, for example, one of our competitors, a good company, Skycatch, is partnered with a Japanese heavy equipment manufacturer called Komatsu. Other partners, other competitors like a Kespri or a Airware or Redbird would be partnered with a John Deere or a Caterpillar, and we're partnering with Autodesk. And so the question is this really more, where do you want your integration? Do you want it to be in your heavy equipment, like your bulldozer, or do you want it to be with your software? And we chose the software approach. So we think that the BIM is the big trend in the industry. We think that Autodesk is making great strides in driving that. We think that that's the ecosystem that's going to win in the day. And Autodesk is an investor in 3DR, and we're part of their Forge platform. And our bet is that the deepest integration with Autodesk is going to win.
That leads into my next question about the challenges of gaining traction. I assume that by partnering with Autodesk, which is one of the go-to software for the construction industry, it has made it easier to introduce the technology to potential users.
Absolutely. I wish I could tell you that it's as simple as everybody uses Autodesk for everything, and that's a kind of, it's a homogeneous environment. But of course, it's not. People use Autodesk, but they also use, Bentley, for the file form. Sometimes they use like SharePoint, or maybe they'll just use email, to communicate. Sometimes they can make phone calls. Sometimes they use paper. And so you have to recognize that it's still a relatively fragmented market. But if you're going to settle on one thing, the one thing that everybody does use is Autodesk in one form or another. So we're betting on that spreading.
With the construction industry being the second largest industry in the world, what does that mean in terms of the opportunities?
Construction is an $8 trillion industry, and it is growing very fast. And, interestingly, climate change, when all the rebuilding necessary after hurricanes is only, stressing it even further. It's got a dire labor shortage, an estimated 500,000 workers short due to everything from an aging population, the immigration policies, even things like drug testing and the opioid epidemic has made it difficult to find construction workers who in many states, they have to pass drug tests. And in some states like Colorado, cannabis is legal, but people who fail drug tests aren't allowed to work on a construction site. So it's just one of these things where the industry is dying for automation. They're being held up by a lack of labor. And so anything that can substitute for labor or focus the people on the more interesting, higher value jobs is in demand. So that's not just the scanning and the surveying part, but the supply chain management. And also, you're seeing a trend in actual automation of the construction process itself, with things like drywall sanding robots, bricklaying robots, concrete robots, automated, tractors that drive themselves. Very, very similar to what agriculture went through in its big automation wave over the last few decades. It's now coming to construction, largely because we need automation to be able to keep up with the demand for more buildings.
What do you see as the pinch points in getting greater levels of adoption? Is it getting pilots trained, or is it the use of the BIM methodology?
Yeah, it's more the latter. They aren't pilots per se, so there's no actual piloting going on. We call them operators, because there's no sticks. It's just simply, you push a button on an iPad. It's more important that they understand how to capture the data, how to use the data, than it is they know anything about, the actual operation of a vehicle. And obviously they have to have a Part 107, so they must know something. But, if they touch a stick, we failed. That's the approach. So the word pilot is kind of becoming a little sort of abstract, I guess. But yeah, so Part 107 is a little bit of a barrier, but that's not the biggest barrier. I think the biggest barrier is just to prove to everybody in the industry that introducing these sort of digitization techniques, these BIM techniques, will make their job easier. Will save money, save time, improve quality. Maybe it's simply about time. It just, if you can characterize the site accurately every day, then tomorrow's work will go more smoothly. You know what happened, what didn't happen, where mistakes were made, you can update it. Maybe it'll just improve the, the ultimate quality of the work, so you don't have these kind of, lawsuits and disputes at the end of the project when things went wrong. Maybe it'll anticipate changes that have to happen in a way that don't result in these overruns and change orders that, as you know, the industry has an average of 80% cost overruns because so much changes during the process of construction. That's extraordinary and, reflects a real inefficiency in some part of the industry. We can only manage what we can measure. And so the notion that measuring would get more predictability over the overall cost of the project is in demand. Now, it might be that the ultimate customers are the ones who demand that, the people who pay, rather than the construction companies who get to pass along the charges. And so this push for measurement and digitization is going to come from many directions, including in some countries, the government itself.
Now, are some projects better suited for using drones than others? For example, is a skyscraper in an urban environment a candidate? Or are we talking about larger shopping centers or mixed-use developments in a suburban area?
Yeah, that's a good question. I can hear the urban planner in you, coming up. Yeah, so right now we're focused on commercial projects, typically outside of urban centers. So this would be a place that'd be larger projects. They actually tend to be commercial rather than residential, although both can work. They tend to be of a large enough scale that you can't just scan the thing by walking around with a laser scanner in a few minutes. And typically they involve a lot of earthworks, so moving dirt around, filling holes. It's called cut and fill, and sand and concrete, and grading and all that sort of thing. So, this represents it's probably about a third of construction falls under this category of, commercial construction of a certain scale outside of city centers. And that's the sweet spot right now.
Switching gears, how would you describe the drone market today? And what do you see as some of the key drivers fueling the market?
The drone market has basically had three phases. It was always expected to have three phases. When you look at my first presentations on this back in 10 years ago, 2007, we predicted that there would be the three phases. There would be the technology phase, where we kind of build the kind of core software and hardware to make a drone possible. I was part of that, and today that now is spun out of 3DR and some other companies, and it's now part of the Linux Foundation called Dronecode. It's an industry consortium that does the sort of the Android, if you will, of drones. And so that core technology continues, much like Linux, and that is now an open stack. The second phase was going to be the consumer phase. The consumer phase was going to be turning this complex technology into a simple device that anybody could use, even a kid. This was going to be because ease of use is a critical barrier, and also because the use case for drones as a storytelling tool for video and photography from the air was both clear and legal because of the recreational use exemptions. And then the third phase was going to be data, the commercial era, and that was gated on really three things. Number one, the drones had to be, easy to use and reliable, and we accomplished that in the consumer phase. Number two, it had to be legal, and the Part 107 rules last year from the FAA made it easy for people to get operator certificates without becoming pilots. And three, it had to be useful. And that last phase right now, making the drone data useful, ROI, clear utility, going from nice to have to must have, that's the phase we're in right now.
In your opinion, are we in a proof of ROI phase, or are companies actually getting ROI from the technology?
I think it's still in the sort of spotty ROI. So some companies see clear ROI. Some companies don't see it yet. And then maybe they don't see it because the particular ROI hasn't been identified in their particular sector or company size or projects. Maybe it just takes time to get the message out there. Maybe they don't actually own this equipment. They get it as a service from a surveyor, and they're just not focused on exactly how the service is provided. So I think that, like anything else, like the internet itself or, enterprise software or the cloud, it's not like the entire world switches into it overnight. You basically get early adopters. Those early adopters find ROIs. That creates traction. That allows the technology to spread out to the next adjacent industry. They find their ROIs, et cetera. Construction, anytime you've got the second biggest industry in the world, and this is true for agriculture as well, it's probably going to take decades to find the full utility of this technology. Total stations, those laser scanners took decades. RTK GPSs taking decades. Even GPS itself, even mobile, even the use of iPhones on a construction site as opposed to paper is taking decades. And that's normal. And I think anybody in this industry has to be in for the long haul.
What advice would you give to other CEOs that are leading their companies at this time? It's not about the drone. If you were going to do an application that required a mobile device today, you wouldn't build a mobile device. You just assume an iPhone or you assume an Android device and you'd make an app or you make a cloud service. And I think that's where we are right now. And too many people kind of get into the industry because they're fascinated with the flying robot part. DJI and others have beautifully solved that problem. It's not about the drone. Assume the drone. Don't come into this industry because you're really into flying robots. Come into this industry because you're really into solving a real world problem with data. I know that enterprise SaaS
doesn't sound sexy. B2B, plumbing, data standards, enterprise software integration. I know it doesn't sound sexy, but that's how advanced technologies have real world impact.
What has the last several years in the drone industry taught you?
It taught me that the drone industry moves at smartphone speed. There was the rise of DJI, the pace of innovation, the pace of product change, and also the sort of the increasing, let's say, and lowering prices, et cetera. This means that the commodity cycle kicked in early and kicked in hard. And people early on expected that drones would look more like aerospace. It's relatively slow innovation cycles, typically dominated by large, often Western companies. In fact, it looks like smartphones. Very fast innovation cycles, very tight pricing pressure, dominated by 21st century Chinese companies that they kind of are good at everything in the way that previous generations weren't. So it looks like, a smartphone. And, if you think of it that way, you focus on the software, not the hardware.
Is there anything that we missed that we should talk about?
The only thing that's kind of interesting we touched on is the notion of a platform for, this commercial era. And, I think we are going to see that for various reasons that there is a demand for choice and an open platform. We love DJI. We support DJI. Our customers love DJI. But in some cases, there is, government in particular is keen to get an open standard, maybe certification, a certified stack, maybe a stack that's been sort of, tested as cyber secure by a third party. And so I think, as we get really practical about the use of these, there's going to be a increasing demand for an Android-like alternative. And Dronecode as part of the Linux Foundation. This is Intel and Qualcomm and 3DR and Unique and others is just now going through this process with agencies to discuss things like certification, security, transparency, and some of those other things that some of the government customers require of a drone. And so I think you're going to start to see, the emergence of an open platform from those companies that solves these particular commercial demands for secure and certified platforms.
And my final question, Chris, what message would you like to leave listeners in regard to drones and the future?
Whoever you are, you probably know something about the world, some other domain where drones could be useful. Think really hard about actually, how do you save time and money? How do you solve real world problems with drones? How do you go from a nice to have to a must have? And once you have that answer, the drone part actually is surprisingly easy. So what we need is better problems, not better drones right now.
That's it for episode 126 of the Drone Radio Show. I hope you enjoyed hearing from Chris Anderson of 3D Robotics. I'm very honored to have Chris as a guest on the podcast, and I want to thank him for taking the time to speak with me. If you want to learn more about 3DR or want to connect with Chris, check out the website at 3dr.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1 per month, you can help defray the costs of production. To donate, go to patreon.com/Drone Radio Show. Thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.